Mean, median, and mode are each measures of central tendency and can be calculated individually and used individually as representative of a whole data set. On the other hand, if you actually calculate all three of them and compare them, they actually can give you some information and infer some information about the distribution of your data. And there are a couple of specific ones that I want to go over right now, such as when you calculate mean, median, and mode, and they turn out to all be very close to each other. What does that tell you about your data set? Well, I'll give you an example data set, which will look like that. And I'll do it in their frequency table format. And maybe our data, very even, oops, that's supposed to be a 50, 60, and 70. And here's how often each data measurement occurs. And you'll notice that it's very symmetric, right? So if you were to draw a histogram of something like this, then it would look something kind of like this, just as a ballpark representation, which as you get into continuous variables, you can see is your classic bell curve, or at least a bell-like curve, normal distribution-like distribution. And in this case, the mean turns out to be 40. The median turns out to be 40. And the mode turns out to be exactly 40. Now, I engineered this data list to be perfectly symmetric. If it's not perfectly symmetric, then there will be some variations between these measures. But if they're all close to each other, then that does infer that it's symmetric, because if it wasn't symmetric, then the median would tend to drift to whichever side most of the data is on. And if it wasn't symmetric, also the mean would also go towards the larger values, or the most frequent numbers. And so you end up with some differences here. So this is a nice symmetric bell shape, normal distribution. And that's when they are all close to each other. Another possibility is what happens if the mean and median are close to each other, but the mode is different. So that should imply that the distribution is in some way not a normal-like distribution. It's not bell-curved. So let's look at what this might look like. And we can look at this as an original data set. The mode is 1, so clearly that's the most frequent. And maybe it could look something like this. 3. Oops. Like that. If we were to draw this graph, of course, the largest, most frequent bar is the 1s, and then in fact it goes down to 3, 4, 5, 6, and then the 7s are also a very high bar. And if you think about this in terms of kind of curves, it's kind of an inverse bell-shaped. So that we have symmetric extremes at the two ends, which puts the mean and median both at about the same point. Because it's symmetric, that's why the median is in the middle also. And of course, the median is in the middle, which means the extremes are not too far off from each other in terms of frequency. If there were far fewer 7s, then you'd see more difference between the mean and median. But the mean and median being the same implies the symmetry with some extremes out at one end. And that's a classic sort of inverted distribution where you get the most of the data is at the extremes. Here's a different situation where we have the median and the mode are close to each other. In this specific case, they're both 6. And the median is really quite a bit different. What is that telling you about your data and your data distribution? Well, let me give you an example of a data set. We might have something that looks like this, and then a really big number. And if we look at this as a histogram, you know, we might have R4, R5, of course R6 is very big, 7, and then, you know, way out here we have, you know, 1,000. And there's only one over there. We have 1, 1, 3, and 1. So what this is telling you is that there's a big outlier, especially when there's such a big difference between the median, mode, and the mean. This number, it's telling you that, you know, you have some really, you know, big outlier kind of number, because, you know, having a single huge number doesn't actually change the median particularly, because it's just the geometric middle. So it doesn't matter what value is here. This could be an 8 or 1,000, and the median actually stays exactly the same. The only time the value is taken into consideration is in the mean. Right? That's when you add up each individual, or each individual counts towards the sum and counts towards the mean. So when you see that kind of difference between median and mean, you have some really big exceptional values. Here's another example in which all of them seem to be different. What does that imply about your data? I got this mean, median, and mode from the following data list. Again, I used a frequency table format. And we have our progression of data points, data measurements. And here are the frequencies. Notice the clear pattern in the frequencies. If we were to graph this as a histogram, it would look something like this. Notice, you know, the triangular distribution pattern, where we have, you know, this is 5, 15, 25, 35, 45, and 55, and this is happening 10 times, 20 times, 30, 40, 50, and 60. That nice triangular pattern. Clearly, this last interval is going to be your mode because it's happening the most. And, you know, the mean and median are all, you know, spread out. The geometric middle of a triangle, right, the centroid, is going to be about here, which is 45. And then, you know, if you average them all together, it gets to be a little bit lower than that. That's your 38.35, 38.3. Now this is just one example in which they're all different. If the mode, instead of being 55, was, you know, 20, well, that's going to be something really different. And there are an infinite number of possibilities. What I've done in this video is just give you a couple of scenarios. Each time you have a mean, median, and mode set, it's going to be from a different data set with a different distribution shape. And you have to kind of ferret out each time, why is that difference between the mean, median, and mode there, and what does that imply about your distribution?